India's power grid is a sprawling, unpredictable web. Voltage fluctuates constantly, and the physical infrastructure is pushed to its absolute limits. The environment itself is hostile to standard electronics. Hardware must survive freezing winter fog in the north and blistering, sun-baked desert summers in the west. For decades, businesses relied on a dumb box approach to survive these conditions. Standard inverters and legacy lead-acid batteries sit passively, reacting only when the power drops, while quietly degrading with every charge cycle. This reactive setup creates a cycle of persistent sunk costs. Facilities pay high commercial tariffs for grid power, routinely replace dead batteries, and burn expensive fuel in noisy, inefficient diesel generators. Solving this grid instability requires a cyber-physical system, a mechanism where physical hardware is actively monitored and controlled by predictive computer algorithms. Surviving extreme grid volatility requires outsmarting the grid itself, using edge intelligence, processing data locally at the point of consumption rather than just storing power. This is the Pure Power 30. While it resembles a server rack, it operates as a complete energy command center, processing gigabytes of telemetry. The foundation rests on advanced lithium-ion cells. Engineered for rapid charging, these modules last 15 years, removing the lead-acid replacement cycle. But reaching that lifespan in extreme climates requires an aggressive approach to temperature control. That is the role of nano-phase change material, or nano-PCM. Nano-PCM is a fire-retardant layer that physically absorbs excess thermal energy. As this diagram shows, it neutralizes heat before it can reach the core, maintaining a safe operating window between -10 and 60 degrees Celsius. Without this embedded physical thermal intelligence, achieving hospital-grade safety and long-term hardware survival in sweltering industrial environments is impossible. Above the thermal layer, all operations are routed through the system's brain, the integrated motherboard. Instead of separate solar controllers, battery managers, and bulky inverters, everything is consolidated onto one highly efficient board. The standout component here is the 5th-gen Battery Management System, or BMS, the electronic system that manages the rechargeable battery pack. This board operates on stochastic control, meaning it uses probability and statistics to handle unpredictable variables. The system utilizes recurrent neural networks to monitor cell-level electrochemistry, thermal dynamics, and grid voltage. Processing these probabilities, the AI identifies anomalies instantly, triggering an over-the-air update before a physical failure occurs. When energy is treated as a probabilistic data stream, the battery actively heals and protects itself instead of undergoing standard passive degradation. At the facility level, this intelligence dictates exactly how a building interacts with the municipal grid and its own solar arrays. The onboard AI functions as an automated high-frequency trading desk for electrons. Its primary objective is dynamic arbitrage, buying, storing, and deploying energy strategically to minimize the levelized cost of energy, which is the total lifetime cost of producing and using electricity. During peak sunlight, the AI calculates the marginal opportunity cost of solar energy. It mathematically determines whether to export excess power or store it. This enables peak shaving, discharging the battery to flatten the evening demand curve and reduce maximum demand charges. For facilities using diesel generators, the AI synchronizes with them directly. It runs the generator only at its peak fuel efficiency point to rapidly charge the battery, then shuts it down, cutting fuel operating expenses by up to 40%. The Pure Power system operates as an active financial instrument that pays for itself by arbitraging time and electrons. Outsourcing artificial intelligence frequently fails in deep tech sectors. Applying generic large language models to complex physical hardware rarely yields safe or reliable industrial performance. Pure Energy addresses this through the domain-first architecture. The system's logic was built by founders who are experts in energy physics. They hard-coded the physical limitations of battery chemistry and the specific business constraints of commercial power tariffs directly into the software. True AI impact in the physical world requires these specialized expert systems, built by engineers who understand the physics of energy as deeply as they understand the code. This industrial-grade intelligence scales down to the residential level with the Pure Power Home 3.0, engineered to support heavy household appliances like air conditioners and geysers. It supports heavy three-phase residential loads with a switchover time of less than 4 milliseconds, so fast that computers and sensitive electronics never register the blackout. This system represents a decade of research and development, protected by over 120 patents, and built specifically for the realities of the Indian ecosystem. By deploying intelligent edge nodes at this scale, Pure Energy transitions Indian homes and businesses into active, resilient participants in a modernized clean energy grid.